For a second, all of a sudden, Dr. Wing started telling me about something, and then all of a sudden it's late. So, need more time between classes. Let's see here. I'll begin with a word of prayer. Heavenly Father, we thank you for this day again. I thank you for these students and this class. Just help us to glorify you, what we do, and help me to answer any questions the students have about the material, Lord. You know my prayer, Lord Jesus. Amen. So guys, ask away. Yeah. Question like 306A. Like 306A. All right, well. Let's see what I can do. I think I have your problems up here. Well, no. Wrong class. Still the wrong class. All right. Hopefully 3's a charm. Oh, here we go. Now I got it. 306A. Oh, yes. I see. All right, so example 1. Suppose you're up against the limit as n goes to infinity of, let us say, the sum j equals 1 to n of, I don't know, 1 plus 3j over n to the 6th power times, I don't know, 1 over n. Now this is harder than your homework problem, all right? And let me scale back from that 6th power and make that a square instead, okay? Then the question is, these are kind of like reverse problems. The question says to rewrite the infinite sum as a definite integral and then use FTC2 to calculate it, all right? So the idea is rewrite this as the integral from a to b of f of x dx for appropriate choices of a, b, and of course f of x, right? All right, so the thing we need to think about, right? So the integral from a to b of f of x dx, we can write it as the limit as n goes to infinity of the sum j equals 1 to n of f of x sub j delta x. Now, as I mentioned, this is not written in stone. Like the Riemann integral allows you to pick any different approximation scheme that you want, but we can choose the right endpoint rule if we like. And I do like to use the right endpoint rule for the purpose of this homework problem, right? So like here, delta x is b minus a over n, and the x sub j is a plus j delta x. Like that's, so this problem involves, so first of all, this kind of problem there's not a unique answer to in terms of the methodology. There's like infinitely many different ways you could do the problem, because you can make different identifications of like what's what. I personally, when I look at this, I go, okay, I'm going to make this, right? Oh, maybe, oof. Well, I'm going to make this. I want to think about this right here maybe. as being my x sub j, you know? So if I think about that as being x sub j, that suggests what? To me, that says a is equal to 0, right? And delta x equals to what? Nobody? I'll give you guys a minute. Three? Delta x would be 3. But delta x has to go to 0 as n goes to infinity. It can't just be 3. But 3 is the right idea. Yeah. No, J is not part of it. So the formula for delta x is b minus a over n. I'm suggesting a is equal to 0. Now I like b be 3. I'll take that. Maybe b is 3. Sure. Delta x should be like 3 minus 0 over n, you know? 3 over n. Now, listen, this is just a... You have to make a bunch of guesses all at once. I'm not saying any one of these guesses stands on their own. It's like all together a package deal. All right. So like, excuse me. So once I say, you know, my delta x is 3 over n, and so my x sub j is 3 times delta x, which is 3j over n, right? So here, my oh, goodness gracious. Sorry guys, I'm kind of low energy today. 1 plus 3j over n squared, I can look at, well, that is 1 plus x sub j squared with this identification, right? So, okay, but worked myself into a... I need to erase up here, okay? Because I want to write the answer up there. But so you guys tell me. So it looks to me like I've got, you know, the limit as n goes to infinity of the sum j equals 1 to n of 1 plus x sub j quantity squared. But how about this 1 over n? What to do with 1 over n? How does that relate to delta x? It's not delta x, is it? It's what? It's 1/3 of delta x, isn't it? Because delta x is 3 over n by our construction, so like delta x over 3 here. Okay? And so now I can see that, oh, okay, well this is the integral from 0 to 3 of 1 plus x quantity squared divided by 3 dx. Now your homework problem's easier than that, right? Like this thing I did with having to divide by 3 didn't happen in your homework problem's easier than this. But it's the same kind of idea. All right, so we must convert the infinite sum. Understand that that infinite sum is a Riemann sum. I suggest using right endpoint rule because it's easy. And once you do that, then we can integrate. How do we integrate this? Well, let's multiply it out. So we got 1/3 integral 0 to 3 of x squared plus 2x plus 1, oops, plus 1 dx, which is 1/3 All right, so the integral of x squared is 1/3 x cubed, right? So we got ourselves x cubed over 3 plus 2 over 2 is just x squared, yeah, x squared plus x. And then FDC2 says you have to take the difference between 0 and 3, right? Now, how does that actually, how you actually calculate that? That's 1/3. 3 to the third power is 27. 27 over 3 is 9. So I've got 9 plus 3 minus 1/3 of, well, 0. Yeah. So that's 18. 18 plus 3 is 21. 21 over 3 is 7. The answer is 7. That's actually kind of amazing, right? That you can calculate this infinite sum with that little effort. Well, it may not feel like a little effort to you at the moment, but trust me, once you understand what you're doing, it actually is not that much effort that we made here. Other questions? Yep.
For question 301, where it says to take the interval to where big F and 0 equals 0,
Yeah.
is there an extra step that must be done to get big F of 0 equals 0?
Yes.
Or is it just the basic?
Well, it depends on the integral. Let's do a bunch of these. Oh, by the way, the instructions are total madness for part E. It's 10 over x to the 9th. That's really hard to divide by 0 there. I mean, like, to put 0 in, you'd be in trouble. So, like, the instructions to this problem must be modified for part E for sure. And also probably for part L. And definitely for part I. And probably for part G. Problem 301, parts I have not assigned you, thankfully, don't make sense. So, like, here's one. So you're supposed to, so the instructions are find antiderivative what? Big F of x such that what? Big F of 0 equals to 0. All right. So, so for instance, like, if we had, say, f of x equals to 17x to the 10th power, what would we anti-differentiate? We get big F of x equals to what? 17 over 11, x to the 11th, right? But we usually add a constant, right? So then f of 0 is what? 17 over 11 times 0 to the 11th plus a constant equals to 0. So therefore, c is equal to 0. The antiderivative we're looking for is just 17 over 11 times x to the 11th. So the extra step is if we add the constant, we have to make sure the constant is chosen such that big F of 0 is 0. Now, it kind of looks like it's nothing to do. If you're just looking at polynomials, like the polynomial of 0 becomes the constant term, so it's hard to appreciate what's going on here. But on the other hand, if I do like f of x equal to like 2 to the x, for instance, what's the antiderivative of 2 to the x? So how about this? We can basically put f of x equal to the integral of 2 to the x dx. That's the basic idea here, right? What is the antiderivative of 2 to the x?
2 to the x over log 2.
I've got a 2 to the x over log 2, and then I have to what? Add a constant, right? Now, if the question was just to calculate the indefinite integral, right? Like problem 302 just says calculate the indefinite integral. But problem 301 is like find an antiderivative which fits this particular initial condition of f of 0 equal to 0. So now f of 0 is what? It's 2 to the 0 over natural log of 2 plus that constant, right? So what's that tell me the constant's equal to? 2 to the 0 is what? Is 1. So apparently the constant is minus 1 over the natural log of 2. So my antiderivative I'm looking for in this context would be 2 to the x over log 2 minus 1 over log 2. Or if you like, you could simplify the answer 2 to the x minus 1 divided by the log of 2. So that's the extra step. To answer your question, we have to fit the constant to the initial condition, right? This becomes more interesting if I say, like, you know, something like v of t equals 3t cubed plus 7, and x of 0 is, you know, 5. Find position as a function of time. So, you know, dv dt, excuse me, dx dt, my bad. Dx dt is equal to v. The derivative of position is the velocity, which in this context, is 3t cubed plus 7. Anti-differentiate, we get x is equal to 3/4 t to the 4th plus 7t plus a constant, right? But we know that x of 0 is 5, right? And if you plug in 0 into the formula, what do you get? 0, 0 plus 0 plus c. So therefore, c is equal to 5. And the answer here is x is equal to, you know, 3/4 t to the 4th plus 7t plus 5. And there you go. That's the position as a function of time. I mean, excuse me. For a given velocity function, there's not a unique position function, you see, because you can be going the same velocity with respect to different starting points. So to fix a specific position function, you have to be given an initial position to sort of sync up with the velocity function. So that's the meaning of the calculation, if you like. Other questions? Yeah.
So before I see, like, with the example 1, you took 1/3 out of the equation. Can you do that with variables?
What kind of variables?
So say you have like an expression in the numerator and an expression in the denominator. Can you take the expression in the denominator outside of the problem, or is that not allowed?
I'd have to see what you're talking about more. Sorry. I mean, you can pull numbers. We can pull numbers out of sums. We can pull like an expression with n outside the sum, but you can't pull the expression outside the limit. There's like a limit n goes to infinity outside everything, right? So like you're kind of stuck with that.
I was thinking like examples like 316 and 318. They have like a similar.
Oh, like 316 and 318? Like problems 316? Oh, you're asking, I'm sorry, I'm trying to make your question about problem 306, and that is not at all what you're asking. So let's try this again. Let's try this again. So suppose you're integrating from -3 to -1 of something like x plus 1 over x squared. So that's not the problem, but this is an awful lot like, well, I guess I didn't assign 316, did I? But this is sort of like problem 316-ish. I did? What the what? Oh, well, this sheet is lying to me. I better go. Oh, that's right. I redid my enumeration after my first go. You guys can trust what's in Canvas. It's fine. You know, I need to print that out before I end up not working out the right problems for you guys. Okay, so Now, restate your question for me again.
So my question is, can you have the denominator of equations similar to how you take out the 1/3 in
Oh, I don't think so. Like the x variable is bound to the integration. You can't just pull it out of the integration. Now, if there was like an a, like if it was like ax squared, you could like have a squared and pull 1 over a squared out. Sure, we could do that. Supposing that a had no x dependence, but no. So here, the way this is done is just algebra. So this is really x over x squared plus 1 over x squared. All right. And a similar step is possible for the actual one, 316, right? Because 316 says x instead of, x squared. And then you got yourself 1 over x plus 1 over x squared. What's the integral of 1 over x? Well, it's the natural log of the absolute value of x. What's the integral of 1 over x squared? It's minus 1 over x, right? Now, you guys might not know that yet, but you need to learn it, right? We talked about this at length last week, right? The antiderivative of 1 over x is natural log of the absolute value. We talked about that. Let's talk about the x squared. Dx over x squared, that's integral of x to the minus 2 dx, which is integral of x, which is x to the minus 2 plus 1 over minus 2 plus 1 plus a constant, also known as minus x to the minus 1 plus a constant. So just write that as minus 1 over x plus a constant, which I hope is what I did. Well, I haven't written the constant yet, but minus 1 over x is the integral of 1 over x squared. Now, I don't have a constant here because I've got bounds. Minus 3 to minus 1. FTC2, right? FTC2. Oh. And so what's that give us? Yeah.
Do you have to write FTC2 every time you take the bounds?
Would you like to?
I was just asking that.
I mean, if you want to, we could do that.
We don't have, I was just asking because, sometimes you like throw that in. Take your points. I was asking.
I don't always write it. I'm just writing it now because we're just starting it. But logically speaking, that is what we're doing. So, but no, I don't enforce that universally. So plug in the upper one. We've got natural log the absolute value minus 1, minus 1 over minus 1, minus parentheses natural log absolute value minus 3, minus 1 over minus 3. So natural log of 1 is 0, and this gives me, what we got here, 1 minus the natural log of 3, and then this gives me a plus 1/3, so minus 1/3. So in short, we get 2/3 minus the natural log of 3. And problem 316 can be done in a very similar fashion, right? Do you see? So yeah, there's no need to try to pull anything out. Or other questions? Yeah. 321D. P. Sure. All right. Here, I'll do it in the middle. So as a general point of order, at the moment, we don't know much of anything except for algebra and the basic antiderivatives, right? So pretty much the way to calculate is to say, okay, is it an antiderivative? I already know. If it is, great, write it down. Otherwise, do algebra to simplify the expression into something that you do know. That's kind of all you got to work with at the moment. So, the rest of this week, we're going to be talking about something called U substitution. which is going to be, you know, a little bit more of an expansion of things we can do. But this one here, I'll change it a little bit, but this is 321p-ish. And so here, integral from 0 to 1, and you've got u times the cube root of u plus the, let's say, fifth root of u du. That is awful similar to the one that is actually in your homework, but it's not the same. So what should we do? You have an idea, Mia? Or is that just stretching? Just stretching. Oh, man. You guys make me do all the work. All right, so how about this? We do algebra. You guys tell me, what is u times the cube root of u in terms of, you know, u to what power? What do we have? U to what power? Plus u to what power? I heard of 4/3. Do we all agree with that? 1, so u to the 1 times u to the 1/3, u to the 4/3, right? And what's 1 plus 1/5? 6/5, very good. All right, now we anti-differentiate. So we have u to the 4/3 plus 1 divided by 4/3 plus 1 plus u to the 6/5 plus 1 up here in the exponent divided by 6/5 plus 1. What's 6/5 plus 6/5? Blah! Words. What is 6/5 plus 1? 11/5. What's 4/3 plus 1? 7/3. So this is 3/7 u to the 7/3 plus u to the, what did you just tell me, 11/5? 11/5, oops. 5/11 u to the 11/5. Do you guys understand the arithmetic I just did? 1 over a fraction is its reciprocal. All right, yeah, multiply by the reciprocal. So that's just arithmetic there. And what happens when you evaluate at 0? You get nothing. What happens when you evaluate at 1 here? 1 to the 7/3, which is 1, yeah, so we get 7/3. Excuse me, we get 3/7 plus 5/11, also known as, like, you know, 33 plus like 35 over 77, I guess. So that's 68 over 77. There you go. Something like that. Other questions? Does that help? I mean, it should be pretty clear how to do that problem now, right?
Yeah.
Okay.
I don't know why I thought it was so difficult.
It's okay. That's what these problems are for. I would rather for us to get past them being difficult on the homework than on the test, you know. Yeah.
302 would you split it out how you did that? You know how you have the numerator is under a single denominator because a term of the denominator has a single term and the numerator has multiple terms.
Yeah.
Would you split it up just how you did that?
Yeah, if the pattern is something like, you know, the pattern's like this, right? A plus B plus C over D. Then algebra says that's A over D plus B over D plus C over D, right? The thing you can't do is the other way around, right? Like this is not true, right? So we try to get that out of our system. But this is true. And that's exactly the algebra step you need to use to make part B go through, right? How about like part, here's another example for you guys. What if I had the integral of the square root of x times 1 over x times the cube root of x divided by x times 1 over x to the 6th dx? What would that be? You're like, that's an annoying problem is what that would be. I mean, but it's actually not a hard problem, is it? So you have a half plus a third minus 7. X to the 1/2 plus 1/3, and there's a net of 7 in the negative sense. So that's 1/3 plus 1/2 plus 1/3 is 5/6, 5/6. Take away 7. Yeah, 42 minus 37 over 6, I think. So if you add 6, you get x to the minus 42, no, 43 over 6, right? Oh, I can't do math. Let's write it out. X to the minus 37 over 6 plus 1 divided by minus 37 over 6 plus 1 plus a constant, like whatever that is, you know? Assuming I did the math right, like 6 times 7 is 42. So I got a minus 42 plus a 5/6, which is minus 37, I think. So of course that can be simplified, but you know, you'll forgive me if I don't at the moment. The bigger idea here is, you know, if you've got products of power functions, you can use algebra to simplify them into a single power function, which we then can integrate. Yeah? It's not always the case. Sometimes we'll need that U substitution technique we'll start talking about tomorrow. But all right, let me give you your quiz. Let's see here. All right. So the quiz, I'll be writing on the board today. So get a piece of paper out, write your excuse me, name on there. Ay, ay, ay. Problem 1. Yeah, still open notes. Problem 1. Calculate the limit as n goes to infinity of the summation j equals 1 to n of 1 plus 2j over n times 2 over n. Problem 2. Find indefinite integral for a integral of e to the x plus sine of x dx. B is going to be the integral of let's see here, x squared plus x plus 1 divided by the square root of x dx. And then C, well, I'll just do AB for that one. AB, and then problem 3. Calculate the integral from 0 to 1 of x cubed plus x dx. There, I think that's quite enough for your quiz. What are we on, quiz 9? I think it's quiz 9. It's quiz 9, isn't it? Yeah. So I'll try to type these up and have a proper, you know, paper to give to you guys like tomorrow. I'm sorry I hadn't get it today. I was actually trying to do this and I apparently fell asleep. So then I woke up and I was like, well, I'm rested, but yeah. So. And let's see here, 1, 2, 3, 4. Each one of these, problem 1 is like 30 points. Problem 2 is 60 points. Problem 3 is 30 points. So like there's 120 points like usual. And like 10, 10 points is 100%. So just try to do your best. I'll be right back, guys. I gotta print something out. I'm giving a talk in the next period, so I guess I probably should stop the camera. Although I was tempting to like film the students taking tests and quizzes. I should have a channel just devoted to that. You know? There must be somebody on YouTube who just wants to watch people taking tests and quizzes, right?